In this lesson, we're going to delve into the various environments where test automation plays a crucial role throughout the software development lifecycle. Each environment, from local development to production, serves a specific purpose and supports different types of automated testing. By understanding how to effectively leverage automation in each environment, teams can ensure that their software is not only functional, but also meets high standards of quality and reliability. We'll explore how test automation is strategically applied in each environment, helping to streamline the development process and catch issues early before they become critical problems in production. Let's begin with the local development environment, which is the foundation of the software creation process. In this environment, developers initially write and test the code that makes up the software. Automated tests are crucial at this stage, as they allow developers to quickly verify that individual components of the software are functioning correctly. These tests often include component testing, where each part of the software is tested in isolation, as well as GUI testing and API testing, which ensure that the user interface and backend services are working as intended. Additionally, using an integrated development environment, or IDE, developers can conduct white box testing to identify and fix coding errors early in the development process. This early testing is essential for catching issues before they have a chance to affect the broader system. Moving on to the build environment, this is where the software is compiled and tested as part of the build process. The primary goal of this environment is to ensure that the software build is correct and ready for further testing. In many cases, this environment is integrated within a DevOps ecosystem, where it forms part of a continuous integration, continuous delivery, or CI/CD pipeline. Here, automated tests such as component tests, component integration tests, and static analysis are performed to verify that the codebase is stable and free from critical issues. These tests help catch potential problems early, ensuring that only well-tested, reliable code moves forward in the development process. After successfully passing the build environment, the next step is the integration environment. This environment is critical for testing how different components of the software work together when fully integrated. In this setting, the system under test, or SUT, is combined with other systems and tested as a whole. Automated testing in this environment focuses on black box testing methods, such as system integration tests and acceptance tests, which evaluate the functionality of the integrated system without considering the internal structure. Additionally, this is the first environment where monitoring tools are employed to track the behavior of the SUT during testing. Monitoring helps identify any issues that may arise during system interactions, providing valuable insights for debugging and improving system stability. The pre-production environment is the final testing ground before the software is deployed to production. This environment is designed to closely mimic the production environment, allowing for thorough testing of non-functional aspects such as performance, scalability, and reliability. In pre-production, automated test suites are often executed to ensure that the software can handle the expected load and usage patterns. Additionally, this is where user acceptance testing, UAT, typically occurs, with business stakeholders testing the software to verify that it meets their requirements and expectations. The pre-production environment also benefits from monitoring, which helps track the software's performance and identifies any potential issues before the final deployment. Finally, we reach the production environment, where the software is live and being used by real users. In this environment, automated testing doesn't stop. It continues in real time, with the software being monitored for both functional and non-functional performance. Techniques such as canary releases, blue-green deployments, and A/B testing are commonly used to safely introduce updates and assess their impact on users. Monitoring is crucial in this environment to quickly detect and address any issues that arise during actual usage. By leveraging these strategies, teams can ensure that the software remains reliable and performant, even as it evolves over time. In conclusion, test automation plays a vital role across all environments in the software development lifecycle. From the initial testing in the local development environment to the real-time monitoring in production, each environment serves a specific function that contributes to the overall quality and reliability of the software. By strategically leveraging automation in each of these environments, teams can ensure that their software is robust, scalable, and ready to meet user expectations. As you continue to refine your test automation strategies, remember the unique strengths and challenges of each environment to maximize the effectiveness of your testing efforts.